Probability distributions using discrete data. So you need to also understand the qualitative part of this course. A few definitions for you to be safe. So to start with, we must define what a random variable is. So a random variable is simply an outcome that takes a numerical value as a result of an experiment. So there are two types of random variables. There's what we call the continuous random variable, which is measured on a continuous scale. And there's what we call the discrete random variable, which is measured using countable outcomes. 1, 2, 3. So it uses integers. There are no fractions in between or decimals. For the continuous random variables, it takes fractions and decimals. For instance, weight, height, a measure of liquids in liters, time, you could have 1.2 hours. But for discrete random variable, these are countable numbers. For instance, the number of sessions you have in a day, the number of students in a class. So these are discrete. So in the first session of our class, we actually defined the difference between quantitative and qualitative data. Under quantitative, we looked at discrete and continuous data. So from there, I'm sure you're able to remember the difference between the two. So dominate on the discrete random variables, which will help us understand how to calculate our mean, which is expected value, our variance, as well as our standard deviation. So the question will succinctly tell you that this probability distribution is a random or a discrete random variable. So we are told the number of students who are absent from a statistics class with a random variable x, 1, 2, 3, 4, 5, 6, and the probabilities 0.12 up to 0.14, the total probability adding up to 1. So the mean is simply found by multiplying our variable x times the actual probability. So we're going to multiply 1 times 0.12, 0.12. 2 times 0.15, 0.3. 3 times 0.18, can you help me? 8, 0.54. Then we go to 4 times 0.15, we get 0.6. Then 5 times 0.26, we get 1.3. And finally 6 times 0.14, we get 0.84. When you total up this, what we get is called our mu, or the mean. So you could alternatively use this formula, which is expanded version, summation of xpx. So it is 1 times 0.12, 2 times 0.15, up to 6 times 0.14. And the sum total will give you 3.7. That is how we found the 3.7. That is our mean. Anyone behind so far? Are we together? So this question was there in the previous exam. It has appeared already 5 times since your lecturer came. So now we go to the variance. But before I go to the variance, there are other small things that you could be asked. For instance, to find the probability of x less than 3. Which values of x are less than 3? Probability of 1 plus probability of what? 2. So what is the probability of 1? The probability of 1 is 0.12. What is the probability of 2? Probability of 2 is 0.15. When we add them, we get 0.27. So they could also ask you to find the probability of greater than 3. Which numbers are greater than 3? 4, 5, 6. You add their probabilities and add them. They ask you at least 2, means 2 and above. So 2, 3, 4, 5, 6, you add their probability. At most 2 means 2 and below. You get the probability of 2 and probability of 1, and you add them. Anyone lost at this point before I proceed? If it's clear, we can proceed to calculating the variance. So you can see that I'm using 2 methods. You can choose whatsoever is simpler for you. So x squared, I'm squaring this. So 1 squared, 1, 2 squared, 4, then 9, then 16, then 25, then 36. I've squared these numbers. Then I multiply by each of these ones here. 1 times that, this would be x squared times the probability of x. So 1 times 0.12, I'm getting 0.12. 4 times 0.15, I'm getting 0.6. 9 times 0.18, I'm getting 1.62. 16 times 0.15, I'm getting 2.4. 25 times 0.26, I'm getting 6.5. And 36 times 0.14, I'm getting 5.05, 5.04. So our total up this column, 5.04 plus 6.5 plus 2.4 plus 1.62 plus 0.6 plus 0.12. So what I get is what? 16.28. So what I simply have to do is simply to subtract this one minus the square of this one. So the variance is simply given by summation of x squared px minus the mean squared. So 16.28 minus 3.7 to the power 2. So what I get is the variance, which will give me 2.59. 2.59. So that is how we find the variance. Of course, the variance has 2 ways. So what did I say? I squared the values of x to get these values here. After doing so, I multiply the values of x times the probability, value of x times the probability. By doing so, I total up to get 16.28. So 16.28 minus 3.7 squared, not 3.7, but 3.7 squared. So what I get is what? 2.59. Alternatively, you can find the variance in another way that I'll show you. So this is a variance, and meaning the standard deviation is simply when you square root the variance. Standard deviation is very easy. Don't square it, you square root it. The square root of 2.59 will give you 1.6. So 1.6 becomes our standard deviation. So Dr. Sabao is using this book, so I'm sure the method that he used seems a little bit complex, but it's the same. So after finding the mean, you now start subtracting the mean from each element here. 1 minus 3.7, then you square 3.7. The answer you got squared, then multiply by the probability. This is what you get there. 2 minus 3.7 is 1.7. 1.7 to the power 2, 2.89. Please, the mistake that people make in column D using this method is your calculator is in board mass. So if you're going to square negative 2.7 squared, it will give you a negative. That negative is invalid. All square numbers don't have a negative. So please take note of that. So negative 2 squared, your calculator write negative 4, but it's supposed to be negative 2 times negative 2, which is positive 4. I hope you get what I'm saying. So when you square this, you get 2.89. That's when you multiply by the probability 0.15, you get this figure. And 3 minus 3.7, this figure. Square it, this figure. Times the probability, you get this figure until you go to the last number. 6 minus 3.7, 2.3 squared, 5.29 times 0.14, we get that. Then directly, it will give you the variance, which is 2.59. So this is the variance. If you square root it, we get the standard deviation, which is 1.61. Now, I want to teach you how to use this hook because this question has come several times. So your next question that will come in your test is this other, because there are only 2 questions, and I gave you this as your homework. So this is the most likely question coming either in your exam or in your test. So you need to try this to find the mean, the standard deviation, and the variance. Okay. So this will be your homework. Unless there are any questions, anyone left behind? See, this is the easiest distribution, unless you just want to make it complicated on your own.